Okay, hi everyone. It's Sam here again. I am here to answer a few more questions that I have received, and these are all. You will find them on page 25 of the collection of questions document on page 25, and I'm going to tackle them one by one. So the first question is regarding lecture 4, page 41 to 42. My question is why the price we are willing to pay is 675 times 20 instead of 243 times 20. All right, let's have a look at lecture 4, page 41 to 42. Now this is lecture 4. What we have here is this. So there is an option on HSBC. The share price is currently trading at 80. This is I assume it's a call option. It's a strike price 82, so it's slightly out of the money. And there's an option gamma, which is equal to 6, and option theta is 0.0. It's around 4 cents. Option value is 91. Now here, the first problem I have with this is option value. I'm pretty sure is per share, and theta I'm pretty sure is per share. Don't know what in contract terms actually means. It's per share. Okay, you just got to be intuitive about this. The gamma, I think it's per 100 options. So there's a slight inconsistency. Options. Okay, now that aside, when you come to the market and you look at this price which is being shown, what is your first reaction? Now the first reaction is okay, the share price is just a share price. Strike can't change, and these parameters like theta and option value, they won't change unless the implied vol changes. Now what is this 24% actually telling you? It is saying that as far as the market is concerned, the market thinks that in the next 20 days or so, there should be an annualized 24%, or there's a 1 standard deviation chance that there is a 24% of movement, at least on an annualized basis. Now, on a daily basis, that translates to 24 divided by 16, which is 1.5%. In other words, as far as the market is concerned, the market on the whole is expecting that every day there will be around $80 times 1.5%, which is $1.20 of movement, up or down. Okay, and accordingly, the option, the theta, so if you are long this option, the gamma revenue that you will earn will be a half times gamma times the square of the change in price. Okay, and this is the expected, if you like, expected. Now the actual would be a half times, so this 1.2 is just a sigma s all square. Okay, now the actual would be a half times gamma times ds squared, whatever ds happens to be. And then if you turn over to the next page, okay, now purely so we are told that today the stock actually moved not $1.20 but $1.50. Okay, $1.50. Now This is the actual movement, and based on that, so if you were to calculate the expected gamma revenue on a previous page, it would be equal to 422. Okay, now what you actually got was 675. Okay, because the movement of $1.50 is higher than what we expected. And so we ask ourselves, well, what if this pattern of a daily move of $1.50 or higher, perhaps, okay, actually it keeps going and it continues between now and the next 20 days. Let's say it does, okay, then actually every day we can look forward to earning a half gamma times the square of that change. If we really do get $1.50 of movement, then every day we will be getting a minimum gamma revenue of $6.75. In fact, you'll be getting more. You know why? Because your gamma is not constant, and the closer you are to maturity, the higher it becomes. So you will be earning a minimum of $6.75 times 20, but likely to be a lot higher. So that is why we say that you are happy to pay. I think this is a rather silly way of thinking about things, but you are happy to pay the daily accrued gamma revenue, okay, multiplied by 20. Okay, now this 135 is actually for 100 options, so for one share it's 135. Okay. The thing to think about here is, if you want to buy an option, the intuition behind this is that if you want to buy an option, you look at what that option can bring you after you delta hedge it, and on a daily basis you can get 675, and your assumption is if this state of affairs actually continues, if you keep getting $1.50 of movement a day, if you do, okay, then over the entire period you will be making $135 for every 100 shares. Now, from the option seller's point of view, for them, they get paid this amount here, 432, okay, and they end up looking at a loss of 675. So the net loss actually is $2.43. Now that's actually the seller's problem. So for the buyer wouldn't think of that. So of course you might be thinking, okay, from the seller's point of view, well, maybe they shouldn't sell the option at the current price. They should sell it higher, and you are precisely right. They should sell it at such a price that the theta revenue, if you like, that they receive exactly matches the daily movement of $1.50 regularly. Okay, then the seller would be happy, and the price is now at a new equilibrium. Okay, so that's the way to think about this. Now let me have a look at question 2 here. I figured out the answer that I asked earlier. Okay, this is regarding lecture 5, page 46 to 48. Okay, so let's have a look at lecture 5. So 46 to 46. What is this about? Okay, the risk reversal. Now I think we say here, I think that when you are buying, okay, so when you are long a call, of course you are long delta, and when you are short a put, you are also long delta, and then this is called a risk reversal. Now, in practice, you can imagine that if you are now somewhere in the middle, okay, so here you long a call, let's say at 105, and you short a put at 95. So for the long call, you are definitely long delta. Okay. Now, if you long put, you are short delta. So if you short put, you are long delta here also. So you are long and long. Sorry, long delta. Okay. And the reason you are long delta it should be quite obvious. Because although your payoff now goes here, and then it takes a turn, and then it goes that way. You think of it like an aircraft. Okay, you are generally still heading in the northeastern direction, although you are now doing you're doing this, and then you're going up. Okay, so if you are going in a northeastern direction, northeast you go up, and then southwest you come down. Okay, well, you must be long. Okay, otherwise if you go that way, okay, then you are short. But if you go this way, you are long. Okay, and it's just that the way you are long is a little bit different. Now, so here what you have actually is a combination of two options. So there's a put here, and there's a call here, and if you were to add them up, I think approximately it would look, I haven't drawn it very well, it would kind of look like this, and they're meeting here, but you are long delta. Now the question is, if you move to 105, okay, if you look like a couple of slides later, it says that here you are more long, which is to say your long call delta has gone up. It really has. Okay, and your short put is less long because your delta. Okay, let's put some numbers to this. So at 100, okay, your call delta may be so your call delta has a strike of 105, okay, call 105, and your delta of the put at 95. Okay, remember you are short the put, so your long call delta may be let's just say 25. Okay, let's just say 25, and then your short put delta also would be somewhere around 25, if you believe that they are kind of symmetric. Now, when you go to 105, the delta here would go to, so you try to hedge this. Okay, so you short sell on stocks, and you short 50. Okay, and then at 105, the delta of your call will go to 50. So definitely you are more long. Okay, now the delta of your put, it will not go to 0. Okay, let's say 10. Okay, and then your hedge is still at minus 50. So on a net basis, you are certainly long. You're long 10. Okay, so and the more you go up, okay, if you consider maybe not at 105, but let's say 107, okay, so sometimes just be a bit more flexible. So let's say you're here, then definitely you will be long delta and riding all the way up, and your call delta will rise a lot faster than the decrease of your put delta. Okay, that is the reason. I mean, you look at it like this. You got a line going like this, climbing up. Okay, well, you can just see by looking at this that you have to be long delta. Okay, you long delta because for a very simple reason. If markets go up, are you happy? You are happy. Okay, so you have to be long delta here. So here you'll be almost like 75 delta, and then here you'll be 100 delta. Okay, that's the reason. What's next? Okay, now I want to just read the question again and figure out exactly what the student is having problem understanding. I have understood the different paths of changes of the row for puts and calls. I think we discussed that because there are two forces opposing each other in the case of the call, but for the put row, they actually go pretty much in the same, at least in the same direction. But I still don't understand why they are related to delta. I think you can look at it like this. So first of all, we know that if you long a call and short a put, it is equal to F minus X. This is the forever useful formula, and F is equal to the spot price plus the interest on the strike. Okay, now you think of some extreme cases. So let's say the spot price now is 100, and you want to go long a call. So you long a call at a strike of, let's say, 120. Now this is fairly extreme because it's so deep in the money, and then you short a put at a strike of 120. Now I'm willing to bet that, who knows, so the delta of this one may be, it might be 98 or something, and then the other one will be the delta of 2. They have to add up to 100. Okay, they must, because you are long call short put. Put call parity means you are long the underlying. Okay, now if you have a situation like this, then in order to hedge this call and put package, of course you can just use the future. Of course you can. But if you were to break it down like this and you ask yourself, all right, if I was to hedge the individual components to make them delta neutral, where do I pay my attention to? Of course you pay your attention here. Here the delta is so low, there is nothing to hedge. You can practically ignore it. Okay, now you think of another situation. So spot price is still the same. Okay, but this time you have another. So now you are long a call. Oh, sorry, no, I made a mistake. This should be long call. Let's say long call at 80. Okay, so deep in the money. That's what I meant. I'm so sorry. So deep in the money. So you have a very, very high delta. Okay, now let's say you are long. Sorry for confusing you. So long the call at 80, short the put at 80. So the put has very little chance as of now of being in the money. So most of your attention will be focused on the call. And when you hedge, you pay most of the attention to the call option. Now let's say now you long a call at 120, okay, and you short a put at 120. Now the situation is different. Okay, so the put delta would be may well be like 98. Okay, and it's put delta is a negative delta, but you are short the put, so it's a positive delta, okay, and the call delta might be 2, let's say, okay, and they still add up to 100, okay. Now here is the interesting part. I know that when I have a long call short put package, I'm basically taking an exposure on the spot price and also the interest on the strike. Now the strike doesn't change, but the interest rate can, okay, and then this is the whole point about rho, okay. So if interest rate changes, how does it affect the left hand side and the right hand side? Well, it affects both sides the same, okay, because this is an equality, okay. So when interest rate changes, it would impact the F on the right hand side, and it would impact the C and the P on the left hand side. So the next question is, how does it impact the C and the P on the left hand side? Well, my answer to you is it depends. It depends where you did your hedging. If your hedging is heavy on the call side, okay, then of course, which means because the call delta is higher, therefore your hedging was focused here, then the interest rate sensitivity is going to hit your call hedging. Whereas over here, for this pair, because most of your hedging was done on the put side, if interest rate changes and it has an impact on F, okay, that must be because it has an impact more on the put delta instead of the call delta. The call delta, you practically can ignore it. It's just you know, tagging along for fun, more or less, at this stage, okay. So that is why we say that when you have a synthetic package of long call short put, and which is equal to the being long the F here, okay, then when interest rate starts fluctuating, so we know it has impact on the F, which means it has impact on the call and the put. We also can predict how that impact is distributed amongst the call and the put, because we know what roles are played here by the call and the put. Okay, now let me give you a third scenario. Okay, so spot price is 100. All right, and now you long a call at 100 and you short a put at 100. Let's say you do that. Now what do you think now happens? So the call delta would be 50 and the put delta is also 50. Now in this situation, you can say with a fair amount of confidence that when interest rate changes and it has an impact on your forward, it's going to impact the call and the put pretty much approximately equally, because you have hedges on the delta covering the call and the put. Okay, so I hope this answers the question. Okay, the next one is okay, hold on a second. And for page 17, rho for different calls, should it be the lower the delta, the less rho is allocated to the call? Okay, let's take a look. The lower the delta, that means the higher the strike. Yeah, I think maybe this should be call. Okay, although the call rho, as you know, it sort of goes up and down, so this is not strictly true everywhere. It just depends on where you are, or whether you are near the money or deep in the money or deep out of the money. Okay. And then question 4, for this question, I think I'm satisfied with understanding basic principles. question 5. So lecture 7. So question 5 here on page 25. Lecture 7, page 17. What happened here if our original position is long call, short put? Long call, short put, short shares. When we early exercise the call, we still short shares and short put. No. That's not what we're doing. The whole discussion regarding early exercise of American options here is this. Okay. Now, if you might remember that I touched upon this, I think at the end of the third tutorial, or maybe in the fourth one. Let me just check that here. Now, regarding early exercise, just 1 second. The discussion is this. Okay, you have a call. Okay, so let's just say you do. So you are currently long a call. It's an American call, and so this time is now. Okay, and this is expiry. And between now and expiry, at some moment, it will pay some kind of a dividend. And let's say you know what that dividend is, or you have a fairly good guess. Okay. So now, at this stage, there are two things you can do. Okay. First, you just hold on to your call. Hold on to it. Okay. Or alternatively, you can exercise your call, which means when you exercise your call, what happens? You're going to buy shares. Okay, you actually need to borrow money. So assuming you're running a trading desk with a zero initial cash balance, so you borrow money. Exercise call, borrow money, you buy the shares. In other words, you take delivery. Okay, and then you buy a put. Now, when you do that, these two are kind of I wouldn't say equivalent. Okay, in terms of the financial outcome, they may not be exactly the same, and that's the whole point. Okay, so either you do that, you hold on to it, or you exercise the call. So you borrow money, which means you have to pay interest, and then you buy the put. That will also cost you. Okay, now if this outlay here, if you were to exercise and then you replace your call with a kind of artificial call, long the shares and long a put, if the cost of doing that is less than what you will receive on dividends, why wouldn't you do it? Because you make more money. Yeah, that is the argument. So the starting position is not you are long a call and what did you say? It's not you are long the call and short shares and short the put. No, you're not. You just long the call and thinking whether you should replace that with a long share and long put position. Okay, and so it really is just an opportunity cost argument, and you can see that a lot of the slides that follow on whether should you exercise or should you not, they're all based on that simple idea of comparative costing. Okay, so I exercise now. If you exercise now, you become a shareholder, and then at this point you will be paid a dividend. If you are just long the option, when you get to this point, you don't get paid a dividend because you are not a shareholder. Okay, that's the difference. Okay, let's have a look at the next one. So question 6. In this slide, he writes that, is there any scenario I would like to pay a bit more for this early exercise call or put? Think about Greece. I think it should be Greeks, but not without a dividend. He doesn't provide answers. So should this kind of scenario be that the dividend is more than the interest? Dividend is more than the interest from now to the dividend payment day, and the amount we are prepared to pay is the difference between the dividend and that interest. But how to solve with Greece? Okay, now let's then take a look at this this question here, question 6. It's regarding lecture 7, starting from page 16 to 29. What is this thing about? Is there any scenario I would like to pay a bit more for this early exercise call put? Think about the Greece or Greece. Okay, let's go to lecture 7, page 16 then. So lecture 7, page 16. Oh, actually it kind of goes on. So where exactly is that page? Here. Think about Greece. Okay. That country comes up again a little later on. Hold on a second. Need to just get to the right page first. Greece again. Okay, so this is the actual page. Is there any scenario I would like to pay a bit more for this early exercise put? Okay, I think here the discussion is like this. This is regarding early exercise of puts. So the logic is kind of the reverse of being long a call. So if you're long a put, an American put, and it's deep in the money, like 20-25% in the money. So there are two things you can do. Okay, one is you just keep the put. Okay, you just keep it. The other, of course, is you exercise. Now, when you exercise, then what you do is you're going to have to sell, or you have to deliver shares to someone. So what you do is, instead of borrowing cash to buy shares, you need to borrow shares. So you have created a short position. So you borrow shares and you sell shares, and you get cash as a result, and then you earn interest on that, and then you buy a call. Okay, you go long a call. Now this would be basically a structural replacement for the put option that you had. Okay, but I think the discussion that I want to have here in answering this question, which is asking me why does this Greece keeps coming up, I think it is this. Now let's just say you first of all you have to remember that if you are long an option, so let's say you're long a put, and the strike price was 100, okay, and let's say the spot is now 80, so it's deep in the money, and you're very happy about that. In fact, it's so deep in the money that I can tell you right now that the premium would be approximately $20. Okay, now, and as the share price goes up and down a little bit, let's say up to 81 or down to 79, then accordingly the premium would become 19 or 21. Okay, so it looks and trades almost like a linear instrument. Okay, so this is the point. An option that is deep in the money in the end isn't really so interesting. It trades almost like what we call a delta 1 linear product. So you can be sometimes mistaken for thinking that, oh, it just looks like a future. Okay, however, please understand that in the end, if it's an option, even if it's a deep in the money option, there are other circumstances that can affect the pricing. Let me give you an example. Okay, so for instance here, I want you to look at the put option on the right hand side. Now I have an option where currently the spot price is 80 and the strike price is 100, and so of course this is very deep in the money, and the put would be about $20, which is just the intrinsic here. Now I know this is pricing a European put, it doesn't matter, don't worry about that. Okay, and I'm using a vol of 25. Now I just told you that if you change this to 79, okay, so the put price will now be 21, more or less. Okay, so you're wondering, well, this looks just like a a forward contract or a futures contract, and what is so interesting about this? Well, what is so interesting about this is, suppose I take a really extreme scenario. Now suddenly volatility, I'm going to really pump it up to, let's say, 75. Okay, this is almost like a World War III scenario. Oh, sorry. The underlying price is 80. So underlying price 80. So originally volatility was 25, and we get a price of around $20. So now I'm gonna pump up the volatility to 75. Okay. Now you can see the put price, even though it's so deep in the money, and it normally doesn't really have a lot of sensitivity to Vega. If you pump it up high enough, okay, it will jump, and the price has now increased by $1.50, which is actually quite a lot. Okay, so now why am I doing this? Well, I'm trying to answer the question, indirectly. The question was, is there any scenario I would like to pay a bit more for this early exercise put? So you may think, well, early exercisable puts are so uninteresting. If it's $20 in the money, I pay 20. Okay, which is what was happening here. But if you, for some reason, anticipate that there can be turning events, which is going to really hit the market unexpectedly and driving volatility all the way up, okay, then maybe you don't mind paying just a little bit more, let's say 10 cents more, 20 cents more, whatever, okay, because you think that you're going to benefit from that. Now, why do we keep talking about Greece? I think these slides were made a little while ago when I'm guessing that when these slides were made, this was at a time when the European markets were experiencing extreme turbulence because Greece, which is a very small country, looked like it may well be leaving the Euro monetary union, because they were on the brink of bankruptcy. If you look back history, you would remember that in around the year 2011, 2010, markets were extremely nervous about Greece running a very, very basically precarious fiscal position, and the government was bankrupt, and it looked like they had no choice but to leave the European Monetary Union. And then people were worried that the whole euro project, the currency, would just simply disintegrate. And that's what we are referring to here. Okay, if we had a scenario like that, then perhaps if we had a scenario like that, and you are a trader, and you thought you could see it coming, and you see that there is a put that's $20 in the money being priced at $20. Okay, would you buy it? You haven't lost anything. You're paying $20 to get $20. Okay, but if volatility, and you can hedge the delta. Okay, and you trade the Vega. But if volatility was to shoot up, okay, then suddenly you have made some free money. Okay, so that is the that was the intention of this question here in brackets. Okay, so Greece was referring to that particular market episode a few years ago when it was extremely turbulent. This makes me think of another question which I couldn't locate. He asked a bonus question: does the call have a maximum value? If it does, what would it be? I thought it over, and I suppose the top value of a call would be the future value of the underlying. Very good, very good. You're on the right track. If you look carefully at the textbook in Hull, they do define the boundary conditions, the maximum for a put and a call. Now, for a call option, actually a favorite interview question sometimes was if the volatility of a call option is infinity, what would be the price of that call option? Okay, it's another way of asking what you're asking. Okay, what do you think? Okay, think for 30 seconds, maybe 20 seconds if you are in an interview. 30 seconds feels like a long time. What do you think the answer should be? Well, a call option, you will never pay more than the current stock price for a call option, and the reason is simple. Okay, now why are you buying calls? The reason you are buying a call is that when the stock price goes up, okay, you want to have a gain, and when the stock price goes down, your loss is limited. Okay, now if you were to just go long a stock, okay, then if the stock, what is your worst case? If you just buy a stock, okay, your worst case is the stock goes to zero, so, and then you lose all your money, which is equal to S. Okay, so if you buy a call, what is your worst case? Your worst case is your call is out of the money. You don't get a chance to exercise. Okay, so if you buy a call and the call option premium was even higher than the stock, why would you even buy the call? Why don't you just buy the stock? Okay, because if you buy the stock, the worst thing that can happen to you is you lose S. Okay, but if you buy the call and you lose more than S, then better just to buy the stock itself. Okay, you're on the right track here to say that the maximum value of a call would be the future value. At maturity, that is the case, but if you discount it back to today, you basically get back the share price. Okay. Do I make some mistakes? No. Well done. So you're okay there. All right. Thank you. I hope this was helpful. Bye bye.